thanks to you for the great talk. We continue with Wouter Koks from the Norwegian University of Science and Technology. And he's talking about a setup of two connected PyPSA models, one for one intraday model and one flow-based market coupling model.
Okay, so I will present some research on using PyPSA for modeling short-term markets and operations. This basically means we're focusing on intraday markets and balancing and redispatch. Why is that important? Well, as more renewables get installed, not only the volatility increases, but also the uncertainty, and intraday markets are an important tool to reduce the real-time uncertainty or the real-time imbalances. This model contains the day-ahead stage, then a sequence of intraday markets and a zonal balancing stage, afterwards a congestion management stage. And so we applied the model on projection of the Norwegian power system in 2030. So here's a broad overview of the model. So it takes input on top from a long-term hydropower scheduling model, which is known as FANCY, and it accounts for the longer-term uncertainties. And from that, we mainly extract marginal costs in the form of water values, which are used in a day-ahead market, and then sequential intraday markets, and then finally a balancing energy stage in which the real-time imbalances are resolved. In these, these are a sequence of optimization steps, and the change in these stages is that the forecasts get updated. So we have a module for that based on a data analysis on how wind and load forecasts change closer to delivery time. And then furthermore, we have the option to limit the flexibility of the hydropower supply stack to model both system inflexibilities and reduce market participation in a simplified, aggregated way. And so after these zonal stages, there's a redispatch stage in which congestions are resolved. Okay, so first a bit on the input. So it is this long-term hydropower model called FANCY, has a lot of connected hydropower systems, and so to take input from that, we decouple the time steps and extract water values. Then for the intraday stage, so as specified previously, so we have the market timing structure when the auctions close, then the forecast updates and the market liquidity. And the key assumption in these stages is that we look at, so what would the market clearing be if all stochastic participants bid their expected production. And we do this because it's very clear what this should or like what is then the difference between reality. It gives an upper limit to market participation, and it also makes it so that we can use PyPSA and reduce computational complexity. So the intraday timing structure, so we have the 3 intraday auctions as in all of Europe pretty much. And then in addition to these auctions, we have a continuous trading stage, which is modeled as an auction, which closes 1 hour before each delivery. And then the residual forecast errors are resolved. So we have some forecast quality analysis, and it's based on NSOE data. And then to analyze this this tool, we calculate the normalized root mean square error as a function of the lead time. And so closer to delivery, the forecast error mainly of wind power reduces significantly. Oops. And this is a key input into the model, because this implies that the forecast error, the root mean square error, has a defined value at each market stage for each delivery hour. Already you can see here that based on our forecasting method, a lot of the imbalance still needs to be resolved in the final stages, continuous intraday stage mainly. So from our model, we compared the output to real imbalance data on the left from NSOE, as well as traded volumes in different intraday markets on the right side. And then we find that the imbalances are quite similar to the ones in reality. But then the traded volume is much lower from our model. Much lower in reality compared to our model. Which makes sense given the assumption of fully trading the imbalance. But it does suggest that the intraday markets can be utilized a lot more, which can be useful from a system perspective to reduce the need for balancing capacity. We also modeled the reduced market liquidity, and using a shortened merit order curve in the intraday stage compared to the day at clearing. And then we find that the price differences in our model are quite low, even with a restrictive assumption on the flexibility, compared to the price differences in the real market data, which I think can also be expected, given that market participants do not per se bid their marginal cost, etc. But so this can be further extended to include more complex behavior. But anyway, after the intraday stage, you have a redispatch stage, and for this we use some data of population density, industrial load, a power grid model for 2030, and a set of 1,000 generators from this long-term hydropower model, which were assigned to coordinates. And then so this is an example of the redispatch output for a single snapshot. So in this case, there's a curtailment of wind energy in the the green downward pointing arc, and so because there's a congestion on some of the lines here, and then there's an upregulation of hydropower, which is the blue upward pointing arc. And we compared the statistics also to the yearly data, and so we use a percentage to model n-1 security, and there the results are at least on the are quite similar, and so between the the real redispatch volumes are in between the volumes obtained for the line capacity assumptions of 80 and 70%. Yeah, so we're on the right order of magnitude. And then for the next steps, so currently the hydropower model is not open source, so we want to change that, maybe using PyPSA or any other suggestions you might have, and make this model more reusable and yeah, more example notebooks, etc., on how to use the code. Also, we are developing a flow-based market coupling module, which should be combined into this model. And we're applying it on a Spanish case study, which also includes solar uncertainty and relaxes some of the temporal decoupling. Yeah, that's it. Thank you. And I would be happy to answer any questions and also to discuss potential collaborations on this, on further steps. So yeah, that's it. I will close the presentation to look at the chats. Okay, so I see a question from Luciana. Yes, we are planning indeed to include flow-based market coupling in PyPSA. Yeah, that's the idea, and so there might be other people working on this that I don't know of. Then I would be extremely interested. Yeah. Timeline. I think it's probably done in the fall.